Okay, so I think the idea for this stream is we want to, I guess, basically figure out like, why do you need more layers, like in a neural net than like one? And so we're going to like implement something similar to this animation. So this is like, these are the layers of, so this is like the input of a neural net where it's inputting two-dimensional points. And so we've like laid out a grid in the input space, and then we're just watching how each of those points, is transformed by each successive layer. And so then we just want to figure out, like, I guess we kind of like want to figure out like how frequently, if I like randomly generate like a neural net of this, like with 2 dimensions with like 3 layers, and then I look at the transform happening in the last layer, like the composed transform, like how frequently can that transform actually be like matched with like a single layer. So yeah, so we're just gonna do that from scratch, and it'll be really cool. I think for now I'll just kind of like, I think for now it'll just be like a single kind of like animation. Like we'll randomly initialize like a neural net and look at its transform, and then we'll animate fitting a single layer neural net to the final layer of the multi-layer neural net. Right? It'll be, so like that'll be like really cool. And so I'm gonna create a new JavaScript file. And fit big, fit small to big .js within the context of neural nets. And then I have to hook that up to my JS. No, my HTML. Okay, and I'm going to delete this because I don't even know why that's there, and I'm also going to delete the style tag. I don't know why that's there. Cool. Very cool. Okay. So, also, wasn't there... No? Okay. Okay, so, so we're just going to have, say, like a 4-layer neural net. We're going to visualize each layer, and then we're going to animate fitting a 2-dimensional or a single layer to the multi-layer. So I am going to use a little bit of the code from previous, in particular, like setting up the grid, because we're gonna have to like use like a grid. I think. Do we need a grid layout? I don't know. I mean, like, it depends how large everything is. So I think the first thing is just to create our neural net. That's the first thing. So I'm gonna copy paste. I'm gonna copy paste that because you know. Okay, so like this is a multi-layer. Also, we're gonna get rid of the weight initializers. And this one isn't going to train, so I don't think we need, like, I don't know what the compile step does other than like pair it with an optimizer, but we don't need an optimizer. So that all looks good. I'm gonna call this guy neural net. Like, this is the big neural net, so maybe I should make him capitalized. That way we know it's the big one. Okay, so then the next thing that we have to do is to visualize the transform, or like to visualize what each layer is doing. We need to create a grid of points, in this case 2 dimensions, and we're just going to follow that grid of points throughout the layers, which means that I also need to extract. You know what would be cool would be if I did everything, like if I just had a constant, if I just said like number of layers. Wow, 4. That's too many. And then like here you'd say like let I equal 0. Let's see, because it already has a layer, so like we're going to count this as one layer. So I is less than the number of layers, and then, you know, just add another layer, right? Why is that not going all the way over? Who knows? So, yeah. So then, so then we want to draw the layers, and each layer is going to get its own canvas, because otherwise it's annoying to, because you have to like calculate the offsets. You know, we don't want to calculate offsets, but first we need to produce a grid of points. And yeah, so that's going to be another number of ticks, like in the grid. So sure, 10. And okay, so like create this is to tell GPT what I'm doing. Create a 2-dimensional grid of points. Yeah, it's going to use linspace, which is fine actually, but I want this to say number of ticks. Also, is that actually the problem with GPT is that it uses functions and they're not necessarily. Yeah, it is linspace. Okay. Oh, also we have to extract the layers, or like the individual. Yeah, individual, because we want to visualize each layer. So gather the layers, you know, as their own models into an array. Okay. I don't know if you want to call it layers, but layers.push. I feel like that's wrong though, because we need to have. I don't know if you can directly get the output. Like if I think you have to separately create a model. So I don't think you can do that. So it's a new model, inputs, neural net.inputs. Yeah, and then I think you have to say inputs. Okay, that looks fine. Neural net layers I.output. Okay, so then we can call like, you know, layers 2.predict, right? And it'll directly give us the thing. As the input. Yeah. Okay, so okay, how's it gonna do this? Because it's already looking kind of weird. Stack. I don't think that's... Is that right? I don't think that's right. Okay, let's see what that looks like. Okay, so we're gonna see what that looks like. Activation is... Oh, yeah. H. And, yeah. No, yeah, so that didn't do it correctly. We're supposed to have like 100 points, so you can't just stack those. So yeah, that's what I thought. But so I'm just gonna say I think I'm just going to say let grid array be that, and then I want to, so like for let I of, yeah, x.datasync, yes, grid array push ij, and then tf tensor 2D. Okay, so let's see what that looks like. I think that's good. I think that's probably good. Yeah, it's like 100 by 2. And yeah. Okay, so we got like a grid. Very cool. And so now we want to create a bunch of canvases to visualize the transformation of the grid by each layer. For each layer, create a canvas to draw the output of that layer, right? Okay, I'm just going to put them all in an array, I guess, which is fine. Number of layers, canvases, push, document, create element, canvas. The width, we will say the width, we'll set them at like a hard, like 300 pixels, I think. pin shot, yes, and like we're kind of ignoring the layout presently. Okay, and then we're then going to create a function to draw each layer. Create a function to draw the output of a layer. Draw layer. I don't think we need to pass in the canvas. So we get the canvas, and you get the context for the canvas, and then you get the, yeah, except I think we want to keep it as an array because we want to keep everything two-dimensional. So that gives us all the points, and then we're just like gonna draw a square for now at each point. So the next thing it should do would be like a for loop over the data. Oh no, what's it doing? Data array, data.length, data array.push. Okay. So for let xy of data. Then we're just going to draw a point. For now, we just want that to be black, I think. And x times 100 plus 150. Yeah, we need like a normalized function. Which I will just copy paste from over here. It's -1, 1, 2, 0, 1. Yeah, except we just want to map. So like either like this needs to be between like 0 pixels and 200 pixels, and then we're mapping the output value of the neural net between, so it's like fitting onto the canvas. So we're going to fill a rectangle, except I'm going to use the normalized function. So we're going to say normalize the x value between 0 and canvas dot width, and normalize y between 0 and canvas height, and then it can be 1, 1. So that should, we're just going to immediately see if that works. Draw the output of each layer. Draw layer I, right? So that should immediately, we should have results on the screen. And we do not have results on the screen. We do have canvases though. So that's something. Number of layers is 3. And grid, append child, canvases, fill rectangle. Well, it should work. I mean, everything looks good. Oh wow, there's points here. I think my normalized function isn't doing what I thought it would. Oh, to a value from 0 to 1. Yeah, I didn't understand my own function. So yeah, so these go from -1 to 1. I think probably the copilot had it right. Canvas width times canvas height. There we go. Oh yeah, like I'm not visualizing the input layer. I kind of should though, like I want to visualize the input layer. So let's do I think do number of layers +1. And then do yeah, but that's going to be highly annoying. Is it? Is that going to be annoying? Well, yes, because the layers, so I think maybe just handle the input, like, because we don't ever update the input layer. So I think I will just handle it separately. So I'll just say like input canvas equals document create element canvas dot. Oh wow, you can do that. That's amazing. Yeah, except it needs to say 300. And yeah, get context, fill style black, and for xy of grid array, fill style black, rectangle, good, good, good. Oh yeah, and then like you have to add it to the document and stuff. So document dot body pinned child input canvas. Very cool. I should put them all in a div because like we need some margin. We need some margins. Also, this is the weirdest. I think something wrong. That can't be right. Well, maybe it was. I don't know. Okay, so so we're looking at, you know, we're looking at compositions of nonlinear transforms in 2 dimensions. And so so kind of like, I mean, one thing I wanted to do was visualize each of these transforms as a single layer. So like if you took this guy and you just interpret it, like if you passed him the original grid instead of the transformed, you know, like what would it look like? Not sure if that's... Or we can just, you know, we'll just stick to the original thing where we're like, okay, we want to animate mapping or like fitting a single layer to this guy. Because, I mean, some of them are going to be very possible, right? Because, I mean, like, almost definitely you can fit a single layer to that. It's really only... I mean, like, here's a conjecture, right? Which is that... Here's a conjecture. Like, you can always fit a single layer to the output of, like, a multi-layer if you never have, like, saturation in the preceding layers. So, okay, so, yeah, okay. So we're just going to, yeah. Like, I'm concerned with, like, I want this, like, I want the animation to be over here, I guess, so, like, you can compare it better. But I don't know how to easily do that. Other than, I think, just making like a grid layout. Let's worry about the layout later. So we're just going to implement the animation logic now. Okay, so we're going to create a single layer neural net, which will look just like this. Create a single layer neural net to fit to the output of the multi-layer neural net. So I'm going to call these are different variables, aren't they? Like if you capitalize versus you don't capitalize, like, isn't it? So yeah, then we're just going to immediately create an animation loop. So animate fitting the single layer to the output of the multi-layer. Actually, we need to get the actual training set. So well, no, I mean, you already have it, isn't it? Because it'll just be the output. So you just need something that says, like, because I guess, like, if we're going to train on, like, every grid point, I mean, so let multi-layer output equal neural net dot predict grid, and then dot, no, just, yeah. Okay, so function, yeah, I wanted to say animate though. So the first thing we're going to do is call, oh yeah, I also need to compile this because I am fitting it. So we need to say compile, and is this deprecated? I don't, oh no, this is saying, yeah, but okay, that's for a regular expression. And like, we're not compiling regular expressions, we're compiling neural nets. It's like it's 2022? Like, who compiles regular expressions, you know? It's like, come on. Okay, what just happened? I don't know what the heck just happened. Yeah, is that cool? That's very cool. And learning rate doesn't matter. Okay, so now we can like fit, I believe. So we're going to say neural net dot fit. That's so weird, like it reversed. The input is the grid, the output is the multi-layer output, and I think you need to specify epochs to be 1. And this is this like returns a promise or something. So like we don't want to, we want to wait for the promise. Oh yeah, but I also need to set up the canvas for the animation, which I didn't do, so we need like another canvas. So oh yeah, yeah, I really should have, we should have had to pass in the canvas. Whoops. And then directly pass in the layer itself. Yeah. And this needs to be modified to pass in layers I. Let me make sure that's still works. Why is that giving me an error? Because that needs to be like that. Okay, we lost. Oops. Layers.predict. Oh. Layer. Okay, cool. We're back. We're back. Alright, so we fit the training data, and then we draw passing in the little neural net, and oh yeah, we didn't create the canvas, so I'm just going to copy paste this. And it's not input canvas anymore, it's little neural net canvas. Little neural net canvas. Little neural net canvas. Little neural net. Little neural net. Wow, I didn't know there's so many instances of the word input. Jeez. Okay. Are we cool now? Okay, so like that should, I think everything should, oh yeah, but this needs to say neural net canvas. Okay. Right. So, oh yeah, we didn't call animate, like we have to actually call it. Animate. Okay, cool. Very cool, very cool. So we didn't, we forgot to do clear rectangle. Forgot to do clear rectangle. Although, you know, it kind of looks cool when you don't do clear rectangle. Right, so, but like, I mean, just kind of eyeballing it, it's kind of fitting it pretty well. Okay, let me do, I guess I'll just put it up here in the draw layer. ctx dot clear rectangle. Okay, so let's yeah, now I mean, it'd definitely be cool, like, if I could you know, like, fit this to here, or like move it over so you can eyeball it. But I mean, you know, you can see like it's not getting it perfectly, obviously. But it's kind of, you know, it's close. It's in the ballpark. Okay, that one's just too weird, really, to look at. I mean, one thing you can immediately observe is that it seems like the if you just have one layer, the like the rows, or you know, like the columns in the original grid, it seems like they kind of have to be equal distance. And so like but like when you have multiple layers, they don't have to be equal distance. Right, it's like, you know, it's subtle. It's like it can kind of, I mean, it can get the overall shape, certainly. Yeah, like it can get the overall shape, except it doesn't have the curviness. Which kind of makes sense because like it's a linear transform up until you're hitting the saturation of the tan H. And like if you're within the bounds, you're not really hitting the saturation. So you're not going to be able to get like any curviness. Yeah, like I mean it's basically just like fitting a linear transform, like it's getting the overall shape. The other thing though is that these, like the multi-layer, yeah, see like this one it's pretty far away. Like it's not really getting the overall shape. So right. Yeah, like it can't pick up like curves. But it kind of fit the overall shape. Kind of. But I think, so for the multi-layer, it would probably be cool if we trained the multi-layer on like a training set first. Because when like you're not like there's a lot of multi-layer transforms that I think like you're unlikely to generate just randomly initializing the neural net. I think you actually have to like train. So I might do that. That might be the last thing I do. Yeah, we'll okay. So we'll do that real fast. I think actually I can like animate. I can animate training the multi-layer neural net. Yeah, like I'll animate training the multi-layer neural net, and then I'll like get its current output, and then train the single layer neural net on the current output. Right. I mean that'll just be cool. Also, like, can you have nested? Can you have nested promises or whatever? because I'm gonna have to have like a nested promise. I don't know if you can have a nested promise. It feels like you can't, but so so I'm going to need to create like a training set, which is just going to be like 4 random points maybe. Cross entropy. What? It really doesn't understand TensorFlow.compile. Okay, so let me create a training set, which I think I will copy paste because, you know, who cares? Yeah, it's just this code, like, we just create, or we just create, we select random grid points for both the input and the output. So, the like training set, and it's, yeah, so we just select by index random points in the grid, and then we're just saying you have to map like this random point in the grid to this other random point in the grid, right? So let me make sure everything, it's broken already. Wow. Ticks is not defined. What did I call it? Grid? Oh, numticks. Numticks. Training size. I don't really need to output this, but yeah. Okay, so like this is our training set. And I don't know why I deleted that, we'll just keep it. But okay, so then we need to train. So yeah, this is gonna be a little, I don't think you can nest like a promise, but we're certainly going to try. So we're going, yeah. Training set 0 to training set 1. 1 epoch. Then okay, so we're going to ignore this layer for right now, and but the draw layer needs to be in a loop. So this needs to be a loop. Actually, you could map it, but who cares? So we have a syntax error. Oh yeah, I can see that. Okay, so we're now fitting the large neural net, and we, and like we can immediately see like we're getting kind of like transforms that we were not previously getting, because like when you train, like you get these weird transforms where like like you're saturating the points basically, and so you get like these concentration, like the grid points like concentrate, which doesn't normally happen if you just sample the weights. So now we're going to see to what extent you can nest like a promise. Oh no, yeah, so we're just gonna see what this does. I don't need, do I need to request, I don't think I need to request the animation frame again. I'm just gonna put that there. So, right? Is this gonna work? It's pretty weird stuff, don't know. Pretty weird stuff. Is this gonna work? Because another fit call is ongoing. I don't know why it's... Oh, maybe if we request animation frame at the end. Yeah. Okay, it works. Apparently, you can nest promises. So, oh, and also, we have to update multi-layer output because otherwise it doesn't know what it's doing. Okay. So, right? And actually we can just get rid of that and then just put it here. Okay. Okay, all right, it's kind of working. It's kind of working. Right, this is a single layer and it's trying to track the multi-layer. And you know, it's kind of doing it. Okay, this is the single layer, this is the multi. Okay, so now the multi-layer though is doing crazy stuff, right? It's like curling these rows. You can't curl a row if you have a single layer. And it's also like, you know, concentrating these points, like it's, I don't know, saturating the grid points. So you have these concentrations of grid points. And you can't do that with a single layer. Right, so that seems to be like one observation we can make, is that if you have, you know, multi-layer like compositions of these like nonlinear transforms, there's like a whole class of like the multi-layer transforms that in particular will like concentrate input points that a single layer cannot do. Like a single layer cannot hyperconcentrate those grid points. Also, I think like the last cool thing to do would be to add color to the points. Right, I mean, yeah, like you're getting these weird concentrations of grid points, and then like you have like these large spaces where you don't have any grid points, and like you just can't do that with a single layer. Also, like I should add a padding or a margin. I don't know what the difference is, but I should add that to the canvases. Let me do that real fast, maybe. If I can find canvases, I don't know if it's padding or margin. Let's just say it's margin. I don't know what the difference is. I mean, they're probably functionally the same anyway. Oh, and also that, I mean, that needs to say style, doesn't it? Because otherwise it doesn't know what you're talking about. I think it needs to be a string. I don't know. See, like, I mean, this one is doing like a weird curve, and like the single layer clearly cannot replicate that curve at all. Yeah, like it's not even close. It's not even close. So I don't know. I mean, like this is cool. There's like there's clearly entire like sets of compositions of like nonlinear transforms, even in the two-dimensional case, where the like the composition, like in this case, composition of size 3, we have 3 compositions. It's producing like these transforms that you cannot produce with a single nonlinear transform. Which kind of raises a question, like, what if for the multi-layer it's just like 1? This is gonna break, I bet, but whoa, it didn't break. That's amazing. So it should be able to track it exactly, right? Because they're both single layer transforms. And it appears to be doing that. Right? Yeah, like it's tracking it exactly. Cool. Okay, so that shows us that you can perfectly emulate the class of single layer transforms with single layer transforms, which is like what you would want. That's like what you would expect. So then, okay, so we'll add one more. I think like my OBS broke or something. Was this broken? Not enough video. Whatever, man. So I have dropped frames. I have dropped 20 frames. Whatever. So this is 2 layers, this is 1 layer. And yeah, like it's getting close, but it's visually different. Wow, like it's already, it can't like replicate that weird. It's already like doing weird stuff that like you can't replicate. Right? I mean, like this is like a weird I mean, again, with like 2 layers, you're already like doing these like point concentrations. Okay, I think I'm like melting my computer here, so I'm going to have to quit. All right, yeah. So like good stream, good stream.